Compaction process is the second step in the major garbage collection cycle. In the second step, either sweep or compact process happens. We will discuss the latter in this video. Hi, I am Rohan and I will quickly apologize for the delay between this video and the last one. It has been a busy few months. Anyway, this video is part of a series of videos where we are exploring how JS manages its memory in depth. So let's get to it. Let's look at the compaction phase next. After the sweep phase, often there are a lot of empty regions all over the memory heap. Now, our browser or our server are not the only processes that are utilizing this memory. There may be other processes that are using this memory, which is finite at the end of the day. So it's a very good idea to release memory pages back when they are not in use. Suppose I have 3 pages with lots of empty regions within it. So if we compact it, then it only takes a single page. Then we can release the other two. What this accomplishes is that we will only consume memory when we need it and then we release it back. So the compaction algorithm attempts to reduce the actual memory usage by evacuating objects from fragmented pages into free regions on other pages. Now, the allocation during evacuation happens in one of two ways. It checks the free list if there is any space available in any of the pages. If so, then it is allocated. Otherwise, it is possible that a new page is created and then a space is allocated within this page, even though it may seem counterintuitive. But during evacuation, new pages may be allocated, and after the compaction is done, the empty pages are then released back to the operating system. Let's look at the compact algorithm in depth. So, as an overview, the compact algorithm follows 3 steps. First, it evacuates an object and replaces it with the new address that is called the forwarding address. After that, the references to these evacuated objects are updated in the existing objects and then the empty pages are released. So, when compact heap function is called, then evacuate and update forwarding addresses function is called first thing. Now, inside that function, we call evacuate and update forwarding addresses in space function with heap spaces one by one. Now, inside evacuate and update forwarding addresses in space function, which is called using a heap space, we iterate through all the pages in the space and we check if a particular page needs to be evacuated or not. This is determined using 2 conditions. First, check the level of fragmentation of a page by examining the ratio of live bytes to the actual capacity of the page, and it should exceed a certain threshold. The second condition is the global evacuation quota. We know about the live bytes in a particular page. If we add them up one by one, they shouldn't exceed this global evacuation quota, which is set up as an environmental constant by the garbage collector. Now, if a page needs to be evacuated, then we iterate through all the objects within that page one by one and check if a particular object is marked or not. If it is, then we clear it, then get the size of the page, and based on the size we allocated some space in one of the existing pages using free lists, or create a new page and assign it some space there. We will get a new address after a successful allocation, which is called a forwarding address. Then we will move the object data to this new address. So what is this forwarding address? In the normal process, whenever we need to find an object data, we use a reference to find it. But in this case, instead of finding the object itself, we find another reference. We can use this reference to go to the actual location where the object is present. So after the object data has been moved successfully, this forwarding address is set in the first word of the original object. This process is repeated for all the marked objects in the page. After the page has been evacuated successfully, the reference to this page is pushed into the evacuated pages list. After that, this process repeats for all the qualified pages in a particular heap space. So this function is called first with old pointer space, then old data space, then code space, cell space, new space, and then finally map space. Notice I didn't include large object space in this. So apparently large objects are not moved. So this space is not compacted, it's only swept. Once the spaces are evacuated, then update references function is called. So if you know a little bit about C++, which is what V8 source code is written in, then we will update the pointers in existing objects using this function. For our discussion, pointers are synonymous to references. Anyway, within this function, we call update references in space with a particular heap space one by one. So we call update references in space. So inside that function, we iterate through all the pages in that particular space, and we iterate through all the objects in a particular page. From each object, we get a list of references to other objects. Let's call this list as fields. So we iterate through the fields one by one. We get the forwarding address from the object field. We check that if it is in fact a forwarding address or not. If it is, then we replace the field reference within the object with the forwarding address. This process is repeated for all the fields that contain forwarding address within an object, and all the objects within a particular page, and all the pages within a particular space. This function is first called with map space. Then after that, old pointer space, then old data space, code space, cell space, and finally new space. After that, the last function, release evacuated pages, is called, whose purpose is to release all the evacuated pages, which we can now safely consider as empty, back to the operating system. So in the function, we iterate through the pages in the evacuated pages list and deallocate them one by one. So finally, after this is done, the main process can then resume, and it will wait for the next compaction cycle. Let's visualize the compaction process with an example. In this case, we will consider one of the heap spaces and just run the entire process on a single page for simplicity. Now, at first, the main process starts, and objects of various sizes are assigned, so they are allocated in the page. Also, these objects are linked to each other via references. Now, at a certain point in time, the marking process happens, which means that all the reachable objects are marked as gray and then black. And after that, a sweep cycle happens, which means that all the marked objects that are set to black are set to white, and then all the unmarked objects that are unreachable dead objects are deallocated. After that, the main process resumes, and at a certain point in time, the marking process happens again, which means that all the reachable objects are marked. But this time, instead of sweep, the compact process happens. So in the compaction, the page is iterated. So each object in the page is checked if it is marked or not. If it is, then it is cleared and it's evacuated. Since this is the only page, a new page is created in the heap space, and a slot of same size as the object is allocated in this page. And then the object is moved into this slot, and its references to other objects are preserved. Also, once the object is successfully evacuated to this new slot, the new address is added as a forwarding address to the old object. So when we need to access the object data itself, then the old reference will point us to this forwarding address, which will then consequently point us to the location where the object data actually resides. This process is repeated one by one for all the marked objects, and the unmarked objects are ignored. Once all the marked objects are evacuated successfully, then all the references are updated, which means that the references will point to the object itself and not to a forwarding address. And this happens for all the objects that contain references that are pointing to forwarding addresses. After that, finally, the evacuated page is deallocated and released back to the overall memory pool. Next, let's increase the scope a bit and include multiple pages in a heap space. First, the main process starts, and the objects are assigned, so they are allocated in the pages. At a certain point in time, the marking process starts. So all the reachable objects are marked as gray and then as black. Then a sweep cycle happens, in which marked objects are set as white and the unmarked objects are deallocated. After that, the main process resumes. And again, after a certain point in time, the marking process happens and all the reachable objects are marked. And then this time, compaction happens. The pages are iterated one by one, and they are skipped or picked based on their level of compaction. When a page is chosen, then it is iterated, and the marked objects are taken into consideration. The mark is then cleared and the object is evacuated into one of the existing pages using free list, or a new page is created and the object is moved there depending on the availability. Also, its references to other objects are preserved. Anyway, After it has been successfully evacuated, the new address is set as a forwarding address to the old object. The process is repeated for all the marked objects in the picked pages, and all the unmarked objects are ignored. Once the picked pages are evacuated successfully, then the references are updated for all the objects that contain forwarding addresses, and the forwarding address is replaced with the actual address. After that, finally, the evacuated pages are deallocated and they are released back to the overall memory pool. So, to summarize, we have discussed the compaction process and the various algorithms that are needed for this process in detail. Mainly the evacuation of objects from a picked page, updating the object references, and then removal of the evacuated page. We also visualize this with a couple of examples. In the first example, we saw the allocation of a new page to evacuate the objects from a picked page, and then the deallocation of the evacuated page. And in the second example, we saw the use of existing pages to evacuate the selected pages to compact the heap memory. In upcoming few videos, we will discuss what memory leaks are and how they can and do happen in our code, and how to detect and fix them. If you enjoyed this video, consider liking and subscribing. Thank you for your time. Have a nice day. Namaskar.